Give me 1 second. All right. You should be able to see my screen now. Wait. Okay. Wait. Give me 1 second. All right. You guys see my screen now? Okay. Here. Hello everybody. My name is Jason, and I will be your instructor for Storm the Castle today. I hope you learned something from me today, and yeah, let's get into it. All right. Here are the topics that we'll be covering today. We're gonna go over the event rules. We're gonna go over the physics and the building tips, and in the end, we're gonna do an interactive activity. All right. Now, what is Storm the Castle? The primary objective in this event is to make a device capable of launching a projectile, which will be a ball in most cases, to a participant set target. What I mean by participant set target is that you set a certain distance, and your score will be calculated based off the target distance, and obviously whether the target was hit or not. Let's check out some video examples of other students who took this event. All right. All right, so as you can see, that like it was basically like you're throwing a ball into the target, like and yeah, that's basically all there is to it. Let's get into it. Oh, here. Sorry about that. All right, so now that you know how the event works, let's get into how we're gonna build this event device. The name of the device that we will be using is the trebuchet. This device was used as a battle machine in the Middle Ages that threw large stones and other projectiles at enemies and castle walls. The trebuchet was especially preferred by militaries because of its great force and great accuracy. All right, here are some examples of trebuchet designs that you'll see in competitions. The most common one would be in the one on the very left. I personally use that one as well. Although they all look very different, they all have the same general concept when we're talking physics. Let's dive deeper into that. Again, the trebuchet is a great device with great power and great accuracy. The most basic concept that you will need to know for this competition is the energy rule. The energy rule is on the rule book, but if your device doesn't follow it, you'll probably be disqualified. The energy rule is basically when the potential energy of the counterweight, which is like this heavy counterweight here, like this, is converted into the kinetic energy of the payload. The projectile, like here, that you're launching, which is in this case the ball, right? The kinetic energy ultimately supplies the payload with energy that launches it into the air. In more scientific terms, the energy of the falling counterweight it launches the projectile using the mechanical advantage to achieve a high launch speed. You will learn more about this in physics class when you learn more about conservation of energy and projectile motion. let's go over some of the basic parts of the trebuchet, which will be important in this lesson. This sling, this string part is called a sling. This arm is a beam. It's called a beam. And this heavy object, which I just said, is called a counterweight. And this pouch, well, it's called a pouch. So like, yeah, it holds the payload, which is basically the projectile that you're launching. And finally, this is the frame, which keeps the trebuchet standing, right? All right. Here are some factors to keep in mind while designing a trebuchet. How long should the beam be? Where should the pivot point be on the beam? How high off the ground should the pivot be? In case you're wondering, the pivot point is here. How heavy should the counterweight and the payload be? We'll go into more detail why these points are so important. Now, we'll go over some important physics concepts which are extremely important when it comes to understanding why everything happens scientifically. If you don't know what conservation of energy, some concepts that you'll need to know are projectile motion and conservation of energy. If you don't know what conservation of energy is, it basically means energy doesn't just go away. It is just converted into something that the total energy in so like the energy doesn't just disappear, right? And the total energy of the system just doesn't change. You'll need to use like projectile equations to derive the position of the payload as a function of time before and after it leaves the sling. The details won't be covered too much here since like you haven't learned trigonometry yet, and a lot of the concepts are derived from trigonometrical equations. All right, now we're gonna go over some tips that would definitely help when building your trebuchet, so that you can achieve great accuracy and great distance. The initial release position is such that the beam on the counterweight side makes an angle of 45 degrees with the vertical. What that means is basically means this, which is the vertical part, and like this angle needs to be 45 degrees, and scientifically it is like scientifically proven, so that like when this is 45 degrees, the initial release point of the payload is the most optimal for achieving a great distance. All right, here's another tip. Basically, this length here should, which is like the longer side of the beam, should be roughly 4 times longer than this shorter side of the beam. All right. The length of the another tip is that the length of the sling, which is this part, this L3, should be equal to the length of the beam on the payload side, which is the longer side, L2. The counterweight should have a mass much greater than the mass of the payload, which is probably pretty obvious. The payload and the counterweight are set by the competition host, so you can't really change the mass of it. Yeah. All right, let's go over some event rules. All right, one important rule is the device dimension rule. A lot of people get disqualified from this because either they have their device is way too big and it will be like counted as cheating. So the launch device, including the stabilizing weights, which is like anything you add on to your device, and all other device components including like these strings and that stuff, it must fit into a 65 centimeter cube. So like 65 centimeter like wide and 65 centimeter long, and 65 centimeters tall. So it must like fit into a 65 centimeter cube. As long as it fits into there, you won't be disqualified. All right. Another rule about device like uh that gets a lot of people disqualified, right? Is the setup rule. All right. There are the first rule is that like your device must fit into like a 1 meter by 1 meter like uh square. You need to be able to prepare for your launch and stuff in a 1 meter by 1 meter square. So basically, you're like preparing all your stuff inside this little square. And another rule is that you must like trigger the device 75 centimeters away from the 1 meter by 1 meter square. So like you pull the trigger around here, or you can do it from here, but I did it here. And the whole point in that rule is so that like it doesn't supply too much energy to the launch, and like there's no extra energy going into the launch, you know. And another important rule is the distance. Okay, so like the distance is measured from a uh okay, so like it basically means that the distance is measured from this point to the middle of the 5 gallon bucket, which is basically your target. So like you're trying to get the ball into the 5 gallon bucket, and the distance is measured by from here to the middle of the bucket. So this is the energy rule straight off of the rule book, which basically I added the slide so that you can actually get a better idea of what the energy rule actually looks like, right? So notice that the counterweight, the sling, the pouch, all that stuff is not on there. So without anything on it, it should be like this when you're ready to launch. It shouldn't move or anything. And uh, this is the 90 degrees position, and when you balance it, nothing should be adding energy to it, and it should it shouldn't really move. All right. Okay. Um. Okay. The counterweight and the projectile rule. So basically, what this means is that the counterweight and the projectiles are set by your competition hosts. So when last year when I took the event, there's a heavier weight and a lighter weight in any competition you go. So like there's a heavier weight and a lighter weight, and then in my case it was 1,500 grams and 1,800 grams. Like it switched between those in different competitions on the long beam, so that like you make a longer beam and a shorter beam for two different weights, counterweights, and like you switch between it in the middle of the event. Oh yeah, I see a lot of people are sending me chat messages, but like I can't really see the chat while I'm presenting. So if you can, please ask Nelson. I think he's a co-host of the meeting. Yeah. So I got a little bit off topic there, but like, so in my case, the lighter weight was usually 500 grams or 750 grams, depending on obviously depending on the competition. But then the heavier weight was 1,500 grams to like 1,800 grams. So yeah. The projectiles. Oh yeah, please don't annotate on my screen. Yeah. So like The projectiles were usually the same throughout the competitions. The 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 more heavier ball was the tennis ball, and the lighter the lighter ball was the racket ball. It's basically like a rubber ball. Yeah. So basically, you're using two different projectiles for two different weights and two different beams. Andrew, you're so funny. Uh, can you erase the screen? Oh, God. Okay. So in the end, when you're submitting the your recording for hybrid and stuff, and like well, it goes. This applies even when it's not hybrid, like even when it's not online or anything. Like you're still going to need to submit a sample test data log. So basically, this is mine from last year, and this is the a graph for my longer beam, and so this is the blue is is when the counterweight was 2,000 grams. The orange was when the counterweight was or no the orange was when the counterweight was 1,800 grams, and the gray was when the counterweight was 1,500 grams. And these are like my distance for certain runs, and like so like run one was like these meters, 8.0 meters, 7.5 meters, 6.5 meters, and like yeah. So you have to like run make it you have to like log down your different your different test runs, so that you know like so that like the hosts know like how your precision and your like accuracy. And same goes for a short beam. All right, yeah. All right, let's do a Kahoot. Um, okay, I'll send a link in the chat. I tried to make this a little bit of a uh challenging problem, or like a tricky problem, because well, I said 65 centimeters cube, and I have mentioned 75 centimeters somewhere for the triggering device rule, which is this one. Yeah, triggering device must be 75 centimeters away from the launch area. Yeah. All right, great job. You can set the counterweight to anything you want. Infinite kilograms. You can get anything. This one should be pretty easy. All right. Yeah. I don't know why you guys got this one wrong, but like basically the competition hosts set the weight and stuff like that on their own. So like you can't change anything. Like the competition hosts already set it. So like yeah. By the way, you are like told ahead of time the counterweight like mass and stuff like that. So like you do have time to prepare it. All right, I said this pretty briefly in the presentation, but like hopefully you guys still remember. L2 versus L3, the sling versus the long side of the beam. Was this a little bit tricky? Well, yeah. It is best for the the length of the beam and the sling to be the same. It is proved like mathematically, but like you guys haven't learned trigonometry, so yeah. Just it'd be very useful to like know that. Keep that in mind. All right. But all right, a lot of you guys are talking to me in chat, but then like I can't really, you know, like talk. All right, good job, Justin. Okay, good job, everybody. I hope you guys learned something from my lecture, and now I will be answering questions. Yeah. If anybody wants to raise their hand and say it out loud, or you can just type it in chat, and I can like talk to you. It is one of the best lessons. Thank you. But it was a little bit short. My bad. Anybody have any questions? Why can't we use mortar style launchers? Um, well, it people trebuchet is more preferred in because of its great accuracy and its great distance, right? And mortars, I'm not too sure because like I didn't really do much. I didn't do much what is it? Like research on mortars, but like I just know that trebuchets were more preferred because of how I don't know, but like yeah, just trebuchets were way more preferred. When does this class end? It ends at 40, but yeah, 4:40. Is there a set location where you'd have to hit? Yeah, you set it yourself. So basically, you're setting your target by yourself, and then your score is calculated by how far it was and whether it hit the target or not. Yeah. Why was the person in the picture pulling the trigger less than 7? Okay, well, they were walking. They were walking. And it was just a screenshot from a video. I don't know if you said this already, but is there a constraint to how many materials you use to build it? Well, as long as it fits into a 65 centimeter cube, then you should be fine. And yeah, just follow the rules. And yeah, uh, you can, as long as like, well, it's not like you're the one who's buying the material, so yeah, I guess there isn't much of a like, limitation, you know. Does the shape of the counterweight matter? No, it does not. But well, yeah. Is the beam connected by a hinge or an axis? Um, the beam is okay. Like connected to what? Projectile. Okay, well, whatever. Wouldn't the rich people buy the best materials? So this is indirectly. Well, yeah, I guess that is kind of true, but like, cause like you could buy a lighter beam and that would be like really useful. So like, I guess you are kind of right. Andrew, is the beam Andrew asks, is the beam connected by a hinge or an axis? Well, it is not connected to a hinge. Yeah. So I guess it's an axis. I really don't know. I Is the bucket a castle? Yeah, I guess that's what they were going for in the when they made the event name. Because uh the trebuchet is what was used to like break castle walls, so I guess yeah. Is Andrew sitting next to me? No. Can they rename the event to Storm the Bucket? No. I don't know. Kind of sad. Okay, well, yeah. Any other questions? Or does anybody want to raise their hand and say it out loud? Storm the Bucket sounds way less epic. Exactly. I agree. William S. Okay.
Is there a weight limit for the trebuchet?
Okay, well, like I said before, I think I said this before, but like the event hosts set it for you. Like they tell you, okay, you you need to build a trebuchet, like you need to use like 1,500 grams and like 500 grams. So like yeah, they tell you ahead of time, so then you can prepare for that.
What is the payload like in the contest?
The payload is basically like the ball, right? The thing that you're launching.
Um,
All right.
will they give
Is
you
that
a payload?
what happened?
Will they give you a payload?
No, you have to buy it yourself.
Oh, can you just buy a lighter payload?
No, like they tell you what ball to buy and like what mass it is. So like yeah, there's no way in cheating that.
Oh.
All right. Aquatic Dolphin asked, "Is the event just building trebuchets?" Yeah, it basically is. What is the payload made out of? I'm okay. Yeah. Ian Leo. Okay.
I mean, like, I think like William, like, could you do something like even if it might be like 20,000 times more expensive? Could you like make the whole frame out of something like osmium and they wouldn't do anything about it?
Well, I don't think
Instead of
anybody
buy a
would
huge
go that.
stack of radium. Would that work?
I don't think anybody would go that far for like a science event. So yeah, I don't
Still
think so.
science or maybe
Yeah.
chemistry.
Well, okay. Okay. Yeah. Can you have your coach or teacher buy the best stuff? Um. Well, you can. Well, it depends on your coach. Not all coaches will buy you your materials. Yeah.
Can I make a
Um.
comment about osmium?
Yeah. Yeah. Go
Now,
ahead.
osmium's like $400 per 30 grams, so good luck finding all the money for that.
Yeah, that's like real expensive, and your parents won't buy it for you. She's trying to say, can you use super dense material? Oh yeah, I guess. Let's take the hand. Oh yeah, right. William. Okay, who's? Okay, yeah, Leah. You've been asking for. Yeah.
Um, if your supplies is more expensive, is that like mean cheating?
Well, there's no budget limit, so like, I guess not. I guess it's not really cheating.
Okay.
It could be hard to like bring it to other places. I would. Okay, we're supposed to go to break a little bit, but like, if you still have a question, you can keep your hand up. So yeah.
Okay, if you made it your troubleshoot like 100, like a hundred, like I don't know, like 5 pounds heavy, would the coaches even, would the judge even like care about that?
Okay, well, as long as it fits into a 65 centimeter cube, I don't think they'll do anything to you. Okay, well, today we're gonna make the break 5 minutes shorter. I'm sorry, but I have something to. Me and my brother have something to do. So like yeah, it's gonna be 5 minutes shorter. So we're gonna be coming back at 4:45, but I'm still gonna be answering questions right now. What if someone buys a pass to use trebuchet for this product? Well, I guess nobody's gonna catch you. Like nobody's gonna know, but like you probably shouldn't do that. It wouldn't. 7. Well, yeah. Okay. We're going to do. Like I said, all right. The break is gonna be 5 minutes shorter. All right. Today, it's gonna be 5 minutes shorter. Sorry. It's gonna. So I start at 4:45. Yeah, we're gonna start again at 45, but I'm still going to be answering questions. Yeah, it is in 3 minutes. Sorry, guys. Can't you use the material? Can't you use the materials like metal to put more weight? If they don't catch you, yeah, I guess you can. Let's take the hand. What? Okay. Leah. Leah. All right. What? Oh. Okay. what would happen if the trebuchet broke down before the payload launched? Well, that's on you. Is Nelson your brother? Yes, he is my brother. Do you get preparation time right before the contest? All right, yeah, that depends on the competition. All right, so like some competitions go like, okay, you need to finish everything in 8 minutes. All right, but like in some and I think in the regional, like the actual competition, the main competition, they give you time to prepare, and then after that there's like a timer that starts ticking. Hope that makes sense. What if you hit your target but it flips and lands upright? Okay, I don't understand that question. All right, we have about 30 seconds left until we're doing the next event. So, yeah, I don't know if I'm gonna answer any more questions, but like, okay, so the next presenter is going to be Nelson, and while he's presenting, he can't look at the chat, so I will be the one. You guys can ask me if you guys have any questions. So yeah. What if your payload is too heavy and hard? Okay, well, I'm gonna end it here. So like, yeah. All right, give me a second. I'm gonna share my screen real quick.